double replacement reactions. Okay, so we needed to look at the solubility rules so that we can predict whether a double replacement reaction is actually a reaction or if it's just a mixing of stuff. So it's only a reaction, a chemical reaction, if we get an insoluble precipitate. So we're looking at AX and BZ, and they're going to swap partners. But it's only a reaction if at least one of these is a solid, an insoluble compound. And so what I think of at this party, if A and Z form an insoluble precipitate, they're not mingling at the party anymore. They went out to the back porch and found that old couch out there, and they're necking. There was chemistry between them, and they are like attached to each other, right? They don't care about the rest of the party. Does that always happen? No, it doesn't always happen. You could have two couples come to a party, and they mix and they mingle, and they may, oh yeah, I'll go home with the same person I came with. Nothing earth-shattering happens. That's not a chemical reaction, that's physical mixing of stuff. So we're identifying whether a chemical reaction has occurred or not by looking, is one or more of the products insoluble? So let's look at these. And I'll show you how to work these. We're going to have two ionic reactants. So we've got zinc sulfate and sodium carbonate. And for these, we do need to indicate state symbols. So underneath, we're going to write the formulas for the ions. Zinc sulfate, zinc is a 2+ ion, sulfate is a 2- ion. When we put those together, we get ZnSO4, and it says it's a solution, it's aqueous. Sodium carbonate solution, Na plus CO3, 2-. We have to look at the charges because that's what tells us how to put these things together. If we don't look at the charges, we're going to come up with wrong answers. So this is going to be Na2CO3, and that is also aqueous, plus. Now we're going to see what happens. So these ions are going to switch partners. So we're going to try sodium with sulfate and zinc with carbonate and see how they get along. So over here, I'm going to rewrite them in a new pairing. So here's zinc, and we'll see how zinc gets along with the other ion, with carbonate. And then we've got sodium and sulfate. I like to look and see if these are soluble or insoluble right now before I go through the bother of writing chemical formulas. Zinc carbonate. I know you don't have that list memorized, but if we go down the list, alkali metals and ammonium are soluble, and then it's a whole bunch of anions. Carbonate is not one of them. So carbonate is mentioned in the group of insoluble compounds. Zinc isn't an exception. So this is insoluble. So we do have a chemical reaction. We have to finish this. So zinc and carbonate are going to be ZnCO3. And we're going to give that the state symbol S for solid. Not S for soluble, S for solid. And then this guy is going to be Na2SO4. And we need to, it's possible that they both end up being solids. Sodium is an alkali metal. All sodium compounds are soluble. So this one will be AQ as well. That's how we predict the products. We swap partners and identify, is one of these insoluble? And if so, which one? Then we have to balance this. We have one zinc, and we have one sulfate, and we have one carbonate, and we have two sodiums and two sodiums. Cool, balanced. Always check. Any questions about that one? Yes?
So only one has to be insoluble?
Only one needs to be insoluble. And frequently it is just the one, but it is possible for the other to be a solid as well. So what happens is you mix these two solutions, the zinc and the carbonate stick together and form a solid, and they fall to the bottom of the beaker. And so you have a change. You've made a new compound. That's one of the evidences that we looked at, was the formation of a solid, the formation of an insoluble compound. Good question. Anybody else? Let's do this next one. Manganese 2 nitrate, Mn2 with nitrate, and potassium hydroxide, K plus OH minus. So we're going to get Mn, NO3, 2, based on their charges. It's aqueous. We could look it up in the solubility rules, but it also tells us. And then KOH is also aqueous. And then we're going to look at what's going to happen here. Well, potassium and nitrate, we're going to see if they hit it off. Manganese and hydroxide. So we would have, and it doesn't matter what order you put them in. Like up here, I put the zinc carbonate first. I could have put sodium sulfate first. That doesn't matter. It is very important, though, that zinc is with the anion. You have a positive ion and a negative ion. You can't have two positive ions and two negative ions. Okay? It's not that kind of party. So I'm going to put the potassium with the nitrate ion. And I'm going to put the manganese with the hydroxide ion. Forgot what I was doing. Potassium and nitrate. Is this soluble or insoluble? Soluble. That's soluble. Potassium compounds are all soluble. Nitrate compounds all soluble. What about manganese with hydroxide? Not soluble. Hydroxide compounds are insoluble except for the group 1 metals, ammonium, calcium, strontium, and barium. So then we have to finish this. We're going to get KNO3. We determined that was soluble, so it's aqueous. And then we get MnOH2 solid. Those are our products. And then we have to balance this. There's one manganese and one manganese. There's two hydroxides, and here's only one. So if I put a 2 here, 2 hydroxides, 2 potassiums, 1 potassium. Okay, put a 2 there. So the potassiums are good. 2 nitrates and 2 nitrates. On these types of reactions, balancing polyatomic ions as units is always a good idea. Any questions? Yes?
I might have forgotten what you said before, but how do you know that they're products and they're aqueous? Like, how are you?
Well, the reactants, I could look them up in the rules of solubility, but it tells me aqueous and solution. But these guys, I'm using the solubility rules. So those are that messy table. So potassium compounds always soluble, so I don't even have to look any farther. Manganese, I look through all of this, manganese hydroxide, I'm not seeing anything, not seeing anything. I get all the way to the bottom, hydroxide ion. Hydroxide compounds generally insoluble, except for calcium, strontium, and barium. Manganese is not mentioned, and so that's what tells me it's not soluble, it's a solid. Okay, that's a good question. Let's see.